All right, the first thing to do in any rational inequality is we have to make sure we have a 0 on one side. So the simplest way to do this problem, which I have is x minus 7 greater than or equal, x minus 7 over x plus 5 greater than or equal to negative 3 is to add 3. So that'll yield x minus 7 over x plus 5 plus 3 greater than or equal to 0. So now the trick is to put them together into one fraction. So we're going to put basically both of these things on the left side into one fraction. So to add fractions together, obviously I need common denominators. So I'm going to go ahead and multiply top and bottom by x plus 5 of the 3. And I can do that because I can multiply anything to the top and bottom. So I end up with x minus 7 plus 3 times x plus 5 all over x plus 5, and this is all greater than or equal to 0. So if I clean up that top, I'm going to get x minus 7 plus 3x plus 15 all over x plus 5. So I can put the x's together. I get 4x. I get plus 8 over x plus 5 greater than or equal to 0. So now we want to find all the zeros and all the undefined values. So the undefined values are just what's going to make the bottom 0, and that's simply going to be x equal negative 5, because negative 5 plus 5 is going to be 0. That's just setting the bottom equal to 0. And the zeros is going to be setting the top equal to 0, which is 4x plus 8 equals 0. So I can subtract 8 and then divide by 4, and I get negative 2. So that's my 0. So I have an undefined value, and I have a 0. So now I want to take these two values, and I want to create a sign chart. So I'm just going to make a generic number line, and then I'm going to put a couple numbers on here. I'm going to put the negative 5 and then the negative 2. Now, why I put the negative 5 first is because it is smaller than negative 2. Now, the one thing I want to denote is negative 5 is an undefined value. So I'm going to go ahead and put a U there for undefined, because that'll be important, because a value can never be equal to an undefined value. So I essentially have this now broken into 3 parts. I have this first part, which is numbers smaller than negative 5. And then I have this region B, which is all the numbers between negative 2 or negative 5 and negative 2. And then part C, all the numbers that are bigger than negative 2. So you have all the numbers bigger than negative 2, between these two, and then less than this one. So you have these 3 regions. So the idea is I want to pick one number in each region. So I want to pick any number that's less than negative 5. Maybe I pick negative 10. And then I pick any number that is between negative 5 and negative 2. Maybe I pick negative 3. And then I pick any number that's bigger than negative 2. Let's say I pick 0. So now the goal is to plug those in to this function, to this 4x plus 8 over x plus 5, and I just want to see if it gives me a negative or a positive number. So if I plug in negative 10 to the function, so let's just kind of do that over here. So if I plug in negative 10, I get 4 times negative 10 plus 8 over negative 10 plus 5. So that's going to give me negative 32 over negative 5, which is positive 32 over 5. And all I really care about is the 32 over 5. So that's going to be a positive number. So when I plug it in, I'm going to get a positive number. That's all I care about for now. Now for the second part, I'm going to do the same thing for negative 3. So I'll do 4 times negative 3 plus 8 over negative 3 plus 5. So on the top, I'll get negative 12 plus 8 over 2, which is going to be negative 4 over 2, which is negative 2. So plugging in -3 gives me a negative. And then I'll plug in 0 to my function. 4 times 0 plus 8 over 0 plus 5, which is going to be 8/5. So that's positive. So that's why we call it a sign chart, because I really don't care what these numbers are. All I really care about is if they're positive or they're negative. So this problem is actually done because I can pick which regions I want now, because I want the regions that are bigger than or equal to 0, so I want the positive regions. So I want region A and region C. So my final answer is going to be -infinity to -5. That's all the numbers smaller than -5, but I'm going to not include -5. Why am I not going to include it? Now it is equal, and usually we would include it, but we can never include an undefined value. So we leave that alone. And then my other region that I can include is going to be numbers bigger than -2. So -2 to infinity. And that one is fine because it's a 0, it's not an undefined value, so I can include it. You can never include ones that are at undefined, but you can include them if they're at 0. So just a quick idea of how you do a rational inequality.